Hello, welcome to a lesson on triangles and exterior angles. In a previous lesson, we examined how the interior angles, let's mark those here, of a triangle would have an angle sum of 180 degrees. In this lesson, we want to look at the exterior angles, or angles formed by extending the sides of the triangle. One of the sets on the diagram at the right would be, pardon the scrolling, angles 4, 5, and 6. I'll mark those there. The theorem states that those angles have an angle sum measure equal to 360 degrees. We're going to look at an examination. I did it once again. Examination of why that may be the case. So let's write down a few details first. Measure of angle 4 plus measure of angle 5 plus measure of angle 6 equal to 360 degrees. So why is it that number? Why is it larger? Easy way to examine that without writing down a formal proof is to look at three linear pairs. Notice that angles 3 and 4 are a linear pair. They add up to 180 degrees. All right, we have that there together. We have the same thing happening with angles 2 and 5. That is a linear pair adding up to 180 degrees. And lastly, look at 1 and 6. That is a linear pair also adding up to 180 degrees. So we have three sets of 180. Notice that the three interior angles, angles 1, 2, and 3, make up those three pairs I've marked. We already know from the previous theorem that those three angles right there add up to 180 degrees themselves. So if we have three sets of 180, one of those is accounted for by the interior angles 1, 2, 3. I'm going to cross one out like it's accounted for. That leaves us with two other 180s, and 180 plus 180 makes 360. So that must mean the three exterior angles, 4, 5, and 6, have to add up to the 360 degrees. Let's take a look at some specific examples. In this example here, you can see we have two external angles marked. The last one is not. Angle 4 in this picture is not marked. If we were to add angles 123 and 92 together, we can find a sum of 215. Then if we were to subtract that from 360, we can find the measure of angle 4. That would be 145 degrees. So we find that the measure of angle 4 is 145 degrees. To find the internal angles, those are all linear pairs. So I'll do one as an example, leaving the others for you. The measure of angle 3 would be 35 degrees, and that would be because angles 3 and 4 together are a linear pair. Supplementary, they need to add up to 180. So you are making sure that those two add up to 180. You can look at the other two as examples on your own time. Here is another example that you can look at. We have two external angles marked 130, 110. That would mean the last external angle needs to make this angle sum come up to 360. I believe that would be 120. Now those three numbers adding up to 160, and then you can figure out that this internal angle must be 60 degrees. P is 60 because 60 and 20, again, 180. Looking at one last example here, this deals with remote angles. So notice that there's only one external angle marked here at 115 degrees. There's a theorem stating that this external angle here that is remote to angles A and B, remote meaning it's not next to those two, it's on the other location, that those two angles, angles A and B, their measures will add up to that 115. And we can try to examine quickly why that's true. But we know that angle B is 79. All right, this is 79. So if I subtract that from 115, I'll be able to find that measure there. So let's see, I'm borrowing. We have 36 degrees. So that would mean the measure of angle A is 36 degrees. So why is it that these two angles add up to 115? Well, since these three internal angles add up to 180, this missing angle here that I haven't yet found, that would be 180. It's also true that the angle I haven't yet found is supplementary to 115, also equaling 180. So then it must be that those match. It must be that they make that same sum. I hope that is helpful.